Hi, hello, this is Giri, teaching 10th Mathematics, the chapter Coordinate Geometry. Here is the introduction and key points of the chapter. Dear students, let us observe this diagram. What can you find in this diagram? Good. Here it seems to be an auditorium or it seems to be a cinema theater, isn't it? Good, it is either a cinema theater or an auditorium in which the seats are arranged for us to sit very leisurely and to observe the situation there. And this is the first diagram. And let us see the second diagram now. Here is the second diagram. Who are all these persons? Good. This is the Indian cricket team who won the World Cup. Here you can find all the Indian cricket players. How many cricket players you can find here? Good, there are around 15 cricket players. And all these cricket players are arranged in rows and columns. For example, if you are asked to find where the Mahendra Singh Dhoni is, then you can find him here. How can you say his position? He is in the top row, and in the top row his position is third position. You can say in that method, or you can say that if we assume that this is the first row, second row and third row, and this is the first column, second column, third column, fourth column and fifth column, then his position is the third column and third row, third column and third row. It is his position. Like this, you can tell the position of any person, isn't it? Good. Now let us observe this. This is the third diagram now. What can you find in this? You can find school assembly going on in the morning hours of the school. And in this assembly you can find the students are standing in rows. Generally, each class students may stand either in one row or in two rows. By asking them to count the numbers, you can find how many students appeared in the class wise, isn't it? You can find the attendance also. In general, the leader of the row or the leader of the class may give us the attendance, how many students are attended from their class, they used to say in the morning assembly, isn't it? In this morning assembly you can find the rows and columns. The students are arranged, or the students are standing as rows and columns. Good. Now you see this. This is our classroom. In this classroom you can observe that the teacher is teaching a map pointing using a projector. Seems it is a VCR class, and the teacher is explaining the concepts, and whereas the students are listening very carefully, isn't it? You can find each and every student is very attentive towards the class. Good. And these students are sitting on benches. You can find all these benches are arranged in rows. The first row, second row, third row, fourth row. Generally, if anybody asks you that where you sit means, you may say that you sit in first bench, or you may say that you may sit in second bench, or you may say that you may sit in third bench, like this, isn't it? And in what place you used to sit in the bench means, you may sit either on the left side of the bench or on the right side of the bench, and you may sit and the middle of the bench also, you can say like this, isn't it? Good. Now this is our classroom. In all these four diagrams you can find all these arrangements are made in rows and columns. Now what is meant by row and what is meant by column? Column means it is the arrangement in vertical direction, and whereas row means it is the arrangement in horizontal direction. You see here, this is a row, this is the arrangement in horizontal direction. It is also a row, horizontal direction arrangement. This is also a row, in which you can find horizontal arrangement. Whereas this is a column, this is a column, and this is a column. Column means vertical arrangement is column and horizontal arrangement is a row. Good. Now let us observe this. You can find some squares and these squares are colored, and some squares are colored in red, and one square is colored in black, and some squares are in white color, and some are in pink, and some are in blue, and one square you can find in navy blue color, and some are in yellow, isn't it, and some are in biscuit colors. And all these squares are arranged in such a way that they are arranged in rows. This is the second row and it is the third row. At the same time you can find columns also. This is the first column, this is the second column, third column, fourth column, like this, fifth column, sixth column, seventh column, and eighth column. These are columns. The vertical arrangement is called columns, isn't it? All these are columns. Vertical arrangement of squares are called columns, and horizontal arrangement is called a row. This is a row and this is also a row. Now in order to locate any square, let us draw one horizontal line. This is the horizontal line of reference and this is the vertical line of reference. This is the horizontal line of reference and this is the vertical line of reference. Now on the horizontal line you can write 1, 2, 3, 4, 5, 6, 7, 8, these numbers, and this 1 means it is the first column, 2 means it is the second column, 3 means it is the third column, and this is the fourth column, this is the fifth column, this is the sixth column, this is the seventh column, and this is the eighth column. These are vertical arrangements and these are called columns. And whereas this is an horizontal arrangement and these are rows, it is the first row. This is the second horizontal arrangement, therefore it is called the second row. And this is the third horizontal arrangement, which is the third row. Now if we are asked to find where this black square is arranged or where this black square is located, then this point or this position of this black square can be explained with two values. One is its row number and second is its column number. Here this black square is in third column and the same black square is in second row. Third column, second row. By this you can locate this black square. Similarly, this red square is located in 7th column and second row. Similarly, this navy blue square is located in 8th column and 3rd row. Therefore, any square of this is located basing on its column number and its row number. Good? Very good. You can give the position or you can find the location or you can denote the location of all these squares basing on their row and basing on their column numbers. Good. Now see, dear students, mathematically this location may be represented by means of a graph sheet. You see, this is a graph sheet in which you can find small squares and each square may be measured 1 centimeter, and this 1 centimeter is again divided into 10 equal parts. Here this length is also 1 centimeter and it is again divided into 10 equal parts, isn't it? Therefore, the sheet which is arranged in rows and columns, or the sheet in which you can find the lines for rows and columns, is called a graph sheet. You can find the graph sheet either in red color or in green color generally. Now this is the horizontal line of reference, and this horizontal line of reference you can call this as x-axis, and this is the vertical line of reference, and this vertical line of reference you can call it as y-axis. Both these axes are meeting or intersecting at this point. This point is called origin. Now you see, on this horizontal line of reference, this is origin, and on the right hand side of origin on x-axis you can find positive values +1, +2, +3, +4 and so on, which is called the positive x-axis. And whereas on the right hand side you can find the positive values, and on the left hand side you have to represent the x-axis with negative values. Therefore it is called the negative side of x-axis. You can find -1, -2, -3, -4 and so on. This is the negative side of x-axis and this is the positive side of x-axis. You can also find a number line here, isn't it? Good. This horizontal line of reference is called x-axis. Good students, if you observe, you can find a vertical line of reference also. You can name the vertical line of reference as y-axis. You see, this is called y-axis. Good. And above horizon on y-axis you can take positive values +1, +2, +3 and so on. And below horizon you can find negative values -1, -2 and so on. You see, both these x-axis and y-axis may divide the total graph sheet or this total plane into 4 parts. This is the first part, second part, third part and fourth part. And these 4 parts are called quadrants. As Q is the first letter of the word quadrant, you can represent this first part as Q1. Q1 means first quadrant. You see, this is Q1, first quadrant. In this first quadrant, x values you can find positive values, and y on y-axis you can find positive values again. Therefore, in first quadrant both x value is positive and y value is also positive. And this is the second part, which is called as Q2, second quadrant. In this second quadrant you can find, you see, these are the x values and the sign is negative. Therefore x value is negative in second quadrant and y value is positive. Therefore first is negative and second is positive. Always you should mention x value in the first place, and in the second place you can write the y value. Therefore any point which is in the form of negative and positive may lie in second quadrant. And this is the third part, which is called third quadrant, Q3. And in Q3 these are x values, means negative values, and these are y values, means they are also negative. Therefore minus minus, this is the third quadrant. And this is the fourth quadrant, Q4, in which you can find positive values on x-axis, therefore x is positive, and on y-axis you can find negative values, therefore y value is negative. This is fourth quadrant. Now any point is in the form of x, both x and y coordinates are positive, that point lies in first quadrant. Now for any point, if the x coordinate is negative and y coordinate is positive, then that point lies in second quadrant. And if x is negative and y is also negative, that point lies in third quadrant. If x value is positive and y value is negative, such points lie on fourth quadrant. And one more thing, on x-axis y value is 0. Therefore for any point on x-axis y coordinate is always 0. Therefore the equation of x-axis is y is equal to 0. And similarly for any point on y-axis the y coordinate may change, but x value is always 0. Therefore x is equal to 0 is the equation for y-axis. Is it clear? Very good. Now you observe this diagram, in which you can find horizontal line of reference x-axis and vertical line of reference y-axis, and this is the scale on x-axis and this is the scale on y-axis. You can find both x-axis and y-axis are intersecting at origin 0, 0. Now let us consider a point. Here you can find this point. At this point, you see on the graph sheet there are so many points. For each and every point there should be one x value and there should be one y value. For example, if we consider this point has x value 2 and y value 1, isn't it? For this point x value is 2 and for this point y value is 1. Therefore, the coordinates of this point are 2, 1. This point represents 2, 1. Good. Now you observe this point. Here, for this point, x value is minus 3 and what is y value? Y value is 2. Therefore, minus 3 and 2 lies here. Now you observe this third point. For this third point, x value is minus 4, isn't it? X value is minus 4 and y value is minus 1. Therefore, minus 4 minus 1 are coordinates of this point. And similarly, this is the fourth point. For this point, x value is plus 3 and y value is minus 2. X is equal to plus 3 and y is equal to minus 2. Therefore, the coordinates are 3 minus 2. You see, if I have given a point, you can write the coordinates, or if I have given coordinates, then you can locate the point where it lies on graph sheet. Therefore, each and every point on a graph sheet should have a pair of coordinates. One is x coordinate and the second is y coordinate. And for any point, for any given point, you can represent the point or you can locate the point on the graph sheet. Clear? Very good. Now this is Rene Descartes. He is a famous mathematician who introduced and developed this analytical geometry or this coordinate geometry. This coordinate geometry is also called as analytical geometry, and this is introduced and developed by Rene Descartes. He is a famous mathematician. He worked more on coordinate geometry and he founded so many theorems in coordinate geometry. Therefore, he is called the father of the coordinate geometry. This Rene Descartes is called the father of coordinate geometry. Good. Now, in order to solve some problems from this chapter, we need some 4 to 5 important formulae. Here, if you observe this diagram, what can you find in this diagram, dear students? Good. You can find an x-axis and y-axis, and there are 2 points. One is A and the second is B, and this is the line passing through these 2 points A and B. That's all we saw in this diagram, isn't it? Now the first and the most important formula is the distance of AB. The distance of the line segment AB, or the distance between the 2 points A and B, where the coordinates of A x1 y1 and the coordinates of B x2 y2. Then the distance of AB is root over x2 minus x1 whole square plus y2 minus y1 whole square. The distance between the 2 points A and B is root of x2 minus x1 whole square plus y2 minus y1 whole square. This formula is used to find the distance between any 2 points. When you know the coordinates of those 2 points, you can find the distance between them. Okay, good. Now the second formula is the slope of the line AB. Here you can find a line passing through both the points A and B. In order to find the slope of this line, the formula is y2 minus y1 divided by x2 minus x1. The slope of the line passing through AB is y2 minus y1 divided by x2 minus x1. And the third formula is the midpoint of the line segment AB is x1 plus x2 by 2 and y1 plus y2 by 2. The midpoint of the line segment AB or the middle point of the points A and B is given by x1 plus x2 by 2, y1 plus y2 by 2. These three formulas are very much useful to solve almost all the problems from this chapter. Okay, dear students, we will solve some problems from the chapter in the next video. Thank you one and all.